This is Module 10, Lecture Notes 20. Last week we talked about acids and bases and how to do reactions with acids and bases. Today we're going to talk about molarity. And molarity is in the acid-base chapter because molarity is the way we talk about how strong an acid or a base is, or its strength. Another way to think about this is molarity is how we express the concentration of a solution. So I always like to think about Kool-Aid because that's something we're all pretty familiar with. So let's say I made a glass of red Kool-Aid. I made this pretty strong, okay? So it would have a high molarity. Let's say this is like 12 molar Kool-Aid, okay? Someone else may like their Kool-Aid a little bit more diluted or a little bit weaker. So it would have a lower molarity. Maybe it would only be 5 molar. So as you can see, the number in front of the unit of molarity tells us its strength. And so you can write out to the side, a larger number means it's more concentrated. Okay, and those are just a couple examples. All right, so molarity has the unit big M. And the way that we calculate molarity is we find the moles over the liters. So how many moles of something are dissolved in a certain number of liters of solution? Okay, let's jump right into this first problem. It says, what is the concentration, which is another way of saying what is the molarity, of hydrochloric acid if there are 2.6 moles in 346 milliliters of solution? So we want to know how strong or what the concentration of this acid is. And the way we do that is using the formula above for molarity. So we know molarity is equal to the moles divided by the liters. Well, they've given us the moles, so we can put 2.6 moles on the top. And the thing you have to be careful about with these problems is making sure that your volume unit is always in liters. And here they've given us milliliters. It's probably been a while since the first unit. So remember, we learned King Henry died unexpectedly drinking chocolate milk. And if we're over here at milliliters and we want to get back to our base unit of liters, under the U, we just need to count 1, 2, 3 jumps to the left. And then you can do that with your decimal. 1, 2, 3 jumps to the left. So this is like having 0.346 liters. You'll do that in your calculator. And you should get about 7.5. Now remember, I don't need to keep all of these digits on the calculator because my moles were only measured to 2 sig figs. So we should really only keep 2 digits or 2 sig figs in our answer. So just try to be cognizant of that. And then our label is just a big M. So that is our concentration or our molarity of our hydrochloric acid. Our next problem again asks us for the molarity, but this time they've given us 6.78 grams of potassium hydroxide dissolved in 150 milliliters of water. You will definitely see some problems like this as you're working through your homework where you have to first find the moles before you can use the molarity equation. Okay, so let's do that over here off to the side. If I have 6.78 grams of potassium hydroxide, do you remember how to get to moles? If grams are on the top and I don't want them anymore, I need a number that is going to cancel out grams. What is this grams of? You will need to pull out your periodic table and figure out the molar mass of potassium with an oxygen and a hydrogen. You will be adding up the atomic masses of your formula and putting that here. Okay, so I'd like you to take a second and do that and get the molar mass of KOH. Okay, so when I added up potassium, oxygen, and hydrogen, I get 56.11. I'm going to say that we have 56 grams per 1 mole. Okay, so we can cancel grams on top, grams on bottom, and if you divide 6.78 by 56, I get 0.12 moles. Okay, now you are set up to use your molarity equation. Moles go on the top and liters go on the bottom. 150 milliliters is the same as 0.15 liters. Okay, and you can see in our problem above, you can go back and review how we moved our decimal point. So putting that in your calculator, you get 0.8 molar for the strength of our potassium hydroxide. Which of these molarities is more concentrated? This one is. The higher the number of molarity, the more concentrated your solution. There's more moles dissolved in your amount of solution. Okay, so that's how you're going to do your molarity problems. All right, right along in the concentration section of this unit is something called dilutions. And I think you have a general understanding of what it means to dilute something. Okay, so let's say I made this Kool-Aid and I decided it was too strong and I wanted to dilute it. I think most of you would agree that in order to dilute something, I need to add what? I could add more water, okay? And that would significantly dilute my Kool-Aid because there'd be more solution for those moles to move around in, okay? And so that's the concept of dilution that you see here. Adding water to a solution will decrease the concentration, okay? And so often in a chemistry setting, you will have a really strong stock solution, okay? You'll have a concentrated acid, and you'll be asked to make a more dilute solution from that. And there's a formula that you can use to figure that out. Okay, this is your dilution equation, and you do need to know it. It says molarity times volume of your initial solution is equal to the molarity times the volume of your final solution. Okay, and so I like to label this part before and this part after. And that may help you think through these type of problems. The one thing that you need to do when you are plugging values into this equation is you must make sure that your volume units match, okay? Because you have a volume on the left and a volume on the right, it technically does not matter if you use milliliters or liters because they will cancel each other out, but they have to match each other to be able to work in the equation, okay? So let's jump into this problem and see how we can dilute something. It says a chemist wants to dilute. That should be a key word in your brain for jumping to this equation. 12 molar hydrochloric acid. Okay, this is our before. He starts with 12 molar hydrochloric acid and he wants to make this. 530 milliliters of a 3.5 molar solution. You can see he's going from a concentrated solution to a more diluted solution. How will he do this? Okay, so let's plug into our equation. M1V1 equals M2V2. The initial molarity is 12. And they don't tell us what the starting volume is. We don't know how much of that concentrated solution he's going to need to use. That's what we're trying to figure out. So that's our variable. We do know that he wants to end up with a 3.5 molar solution, and he wants 530 milliliters of it when he's done. So in these problems, you will know everything except one variable. All right, so now it's time to put your algebra skills to the test. I have a variable that I need to isolate. So remember, you need to divide by 12 molar, bring this down, and this is what you would be left with to punch into your calculator. So your 12 would go on the bottom. All right, go ahead and punch that into your calculator and see what you get for the volume. I'm getting 3.5 times 530 divided by 12. I'm getting 154.6. And what unit should I put on this? Okay, they're asking us for a volume. Molarity cancels. The volume unit that I initially used was milliliters. Remember, we talked about that the volume units are going to match. So my answer comes out in milliliters. All right, so I think it's really important to think about what this number is telling us, okay? So this chemist started with a concentrated solution. So let's pretend here's our bottle of acid, and it's 12 molar acid. It's really strong, okay? And in the end, he said he wanted that diluted. So this number here is telling us how much of that acid he needs to use. So let's say he pours 154.6 milliliters of that strong acid into a beaker, okay? In the end, he wants 530 milliliters of a more diluted solution. And just like I did with that Kool-Aid, remember I took my strong Kool-Aid and I added water to it. That's what this person would be doing to dilute their acid. They would then add water. Okay, so they'd be diluting it with water until they get to 530 milliliters of solution. Okay, so that's how you can visualize a dilution problem. Taking something strong, measuring it out, how much do you need, and then diluting the rest with water. All right, let's work through this last problem together to make sure you have the hang of it. A chemist takes 2.5 liters of a 6.7 molar solution. This is before. And dilutes it, keyword to use your dilution equation, and dilutes it to make 10 liters. This is how much we have after. What is the new concentration? All right, so let's write down our equation. M1V1 equals M2V2. They gave us the molarity before. It's 6.7 molar. They gave us the volume, 2.5 liters. That's what we're starting with. We're going to dilute it, and they tell us we end up with 10 liters. We know the volume. In this problem, we have to figure out what concentration they diluted it to. What's our molarity after we've added all the water? So that's our variable we're going to solve for. When you rearrange your equation, remember to get a variable by itself, you need to divide the 10 down to the bottom. So it should look like this. Okay, so in your calculator, you're going to do 6.7 times 2.5 divided by 10, and you should end up with 1.68 for your answer. Or you could round to 1.7. What units should you use on that? Liters cancel, and we end up with molarity for our units, and that makes sense because they asked us what the concentration is. Okay, you can always do a check in your mind. Does that make sense that if I started with 6.7 and I've diluted it, is my molarity after the dilution less? Yes, it is. So always kind of make sure that the numbers make sense with what you're trying to do in the problem. Okay, hope that makes sense, and we're going to flip over to the back now. Okay, let's flip over to the back of your paper, and we're going to talk about something called titrations. And a titration is what you're going to be doing in your lab today. A titration says it's the process of slowly reacting a base of an unknown concentration with an acid of a known concentration, or vice versa, until enough acid has been added to react with all of the base. Then you can determine the concentration of your unknown. And it does say vice versa, so it really doesn't matter which one you know the concentration of and which one you don't. But the point is that one of your reactants you know the molarity, and one of them you're trying to figure out. So this is very useful if you were to find a bottle of acid or base that wasn't labeled and you aren't sure what strength it is. You can do the process of a titration to figure out what its concentration is. Okay, titrations are always done with something called an indicator. And an indicator lets your eye see the equivalence point or the end point of the titration. And you will know that the titration is finished because you usually see a color change with your indicator. The indicator will turn a color, letting you know that the moles of acid and the moles of base are exactly equal at the equivalence point, and that you should end your titration. Okay, I'm going to walk you through a little bit of the math here during the YouTube lecture notes, but I'm sure you guys will do some more of this in class as you prepare for the lab. Okay, let's go back to our molarity formula that we were doing on the other side. We know that molarity is found by taking moles and dividing by liters. Okay, but in a titration, we are concerned with moles, making the moles of our acid equal to the moles of our base at the equivalence point. So what if we rearrange this equation so that we had moles by itself? How would you do that? You would have molarity times liters to get moles by itself. So this is really saying molarity times volume, right? Because liters is a volume, is equal to moles. M times V equals moles. So we can rearrange the equation to get moles by itself. Okay? And then we can also say that if we want moles of acid equal to moles of base, we could say molarity of our acid times the volume of our acid, because we know that this is equal to moles, must be equal to the molarity of our base times the volume of our base at that equivalence point. because in a titration, the moles of acid and the moles of base are equal. Okay, so this is going to be your main equation for titrations. And look how similar it looks to your dilution equation on the other side. Remember, we had M1V1 equals M2V2. Well, that's virtually the same thing. M of your first thing times V of your first thing equals M2V2. So it's virtually the same equation, but now we're talking about it with acids and bases. Okay, so that's the equation that you'll be using in the lab. I wanted to definitely show you how we got that equation. And then I just want to show you a quick picture so you can visualize what you will be doing. All right, so this is a picture out of my high school chemistry book, so it's pretty old, but it definitely still applies because this is exactly what you guys will be doing in the lab. So I just wanted to walk you through what some of this equipment is called. This piece of glassware that is used for titrations is called a burette, B-U-R-E-T, okay? And you fill the burette with the solution that you know the concentration of. You have to know the molarity of what's in here. And it has tiny little markings on it that are super accurate so that you can get a good reading for how much of it you're going to use. You don't know the concentration of whatever's below the burette. You're trying to figure that out, but you do know how much you have, okay? So up here you know the molarity and the volume. Here you know the volume, but you don't know the molarity, so that's your question mark. When you're ready to start the titration, you're going to open this stopcock and you're going to allow this solution to slowly drain out into your unknown. And in your unknown, you've put an indicator. And in this case, they've used the indicator phenolphthalein, which is going to turn pink when the moles of acid and base are equal. And you can see there's a hint of pink here. So as you're adding this, you're slowly swirling and mixing this. And then all of a sudden, it's going to turn pink. And that tells you need to stop adding your known solution. You're going to take a final volume reading and you'll be able to use the equation that we just talked about to figure out the molarity of your unknown. Okay, hope you guys have fun doing the lab and figuring out your unknown concentration. See ya.